This series of videos will explain as simply as possible everything on the Calculus AP and BC exams, which you will be tested on. Videos are separated by topic, some videos containing more than one. Anything that is only on the Calculus BC exam will be indicated as such. Otherwise, every topic is on both exams. Each video will be an explanation of the topics, followed by a couple practice problems, then a summary of the video. After watching the videos, I would highly suggest doing practice worksheets I've created, which will be in the description. I will try my best to prioritize what will be tested on in the actual AP exam and tell you any tips which I can think of while creating these videos. Feel free to use this as an aid or as a primary resource for this exam. You can get a 5, I believe in you. Let's begin. So, calculus is all about instantaneous rate of change. I'm just going to get this out of the way. ROC means rate of change. You can write that on FRQs, literally anything. ROC, everyone, all the graders, they all know it's rate of change. You can write it. Your teacher's gonna know it. I'm gonna say a lie because it's gonna be easier to write. ROC is rate of change. I'm just gonna say that. I'm not gonna say IROC because I think that sounds stupid. So we're just gonna say instantaneous rate of change. But anyways, what is an instantaneous rate of change? First, we got to look at the difference between average and instantaneous rates of change. An average rate of change is the average amount which a function changes each time the x value is changed by 1 over a given interval. This is simply found by simply doing the y2 minus y1 over x2 minus x1 formula you learned in algebra. So just this guy right here. Now, an instantaneous rate of change is the amount which a function changes at an exact time, at an exact point, or and it's not really an exact point. Most of the times it'll be called a point. I want to focus on the exact point part because that's very important once you get a word point. An exact point means a function at a very specific x value with x being a number which has no end to its precision. So if we have this graph, let's say this thing is 2. This point is x equals 2.000, and that's just repeating forever. It's never going to be a 1, a 2, a 3. Nothing else is going to be in the decimal places except for that 0. I should have made this bigger, but I don't really care. It's not too important right now, but I'll clarify it later when I discuss continuity. All right, so all we have is this. All we have is this y2 minus y1 over x2 minus x1. And, yeah, that's all we have to go off of to try and find the rates of change right now. So let's use the tools we have to try and find instantaneous rates of change, shall we? I swear this is important. I'm not just doing something dumb with this. Let's use the function y equals x squared. We're gonna start using what College Board loves to use, which is f of x. This same thing as y. Probably knew that, but just wanted to clarify just in case. I'm gonna call it f of x. And at the point x equals 2, what is the instantaneous rate of change of x equals 2? So I don't plan on asking many rhetorical questions because I feel like you don't know the answer. So why should I ask them? So let me just tell you that we can take the numbers around x equals 2 to try and get a guess of what the instantaneous rate of change is. This is called a secant line approximation. It's really they do ask like 1 or 2 questions on this every time, and you have to know what this is asking for. So I'm just gonna say it now. If it says secant line approximations, we're gonna do this exact thing right here. I'll tell you beforehand so you remember this, because otherwise you probably won't care. So we're gonna do a guess. We're gonna do whole numbers because I'm not doing decimals right now. That's more work than I feel like doing. So we're just gonna use our little formula here. Sorry, you can see the fade on this. I don't know why it's not all black, but whatever. Okay, we're gonna use this formula to try and guess what the instantaneous rate of change, this guy right here, of this function is at x equals 2. Ignore this. This is just, if I write this, it means, for now, it means what is the instantaneous rate of change at x? We're trying to find x equals 2. So just, that's what that is for now. And it is that. It's always that. It's just, it gets a little bit different definition later on. But for right now, we're going to plug in our numbers, try and guess this. I'm going to use 0 and 4. I'm intentionally not using 1 and 3. I'm going to prove a point using that in like 30 seconds. Bear with me. If we plug those numbers into this stuff, it's like 16 minus 0 over 4 minus 0. It's 4. You get an average rate of change of not 4. Oh, okay, well, yes, 4. Sorry. It is 4. But wow, this is a horrible example. Let's see. Instead of y equals x squared, let's do y equals, I don't think x cubed will have this problem. Okay, let's do y equals x cubed. This is going to be f of x. I'm coming down here to hide that. That's kind of embarrassing. We're not going to lie. So we're going to do the same numbers, try and find x equals 2. So we're going to do 1 and 3. 3 is going to give us 27. 1 is going to give us 1. So it's 26 over, what is that, 2? So we get 13 is our estimate of this number. Or 13 is the estimate using 1 and 3. And let's see, what would our estimate be of 0 and 4? Don't use those. Use this. They get mad if you... We're guessing, so we have to use little squiggly lines. They get mad at that, apparently. But anyways, so this is using 1 and 3. Let's use 0 and 4. I'm going to pick backwards now, but this is 13, and 1 and 3. If you do 1 and 3, your guess of this instantaneous rate of change, it's gonna be, oh my gosh, 0 and 4. It's gonna be 64 over 4, which is 16. And because I don't feel like asking a bunch of dumb questions of like, oh, what do you think is closer to the... It's this one. This one's better. This is a better guess. The actual instantaneous rate of change is 6. So neither of them is great, but it's pretty good. It's a decent guess using what little tools we have. So we're just gonna... It's 6. The instantaneous rate of change at x equals 2. It's 6. Okay, 13 is closer than 16. If you use numbers closer, it'll give you an estimate. So on an FRQ, when you see, oh, given the function f of x equals x cubed, estimate f prime, this is called f prime of x, by the way, estimate f prime of 2, you're going to be like, oh, okay, I got this. It's going to be f of 3. You got to write it like this, but I'll do that later. It's going to be f of 3 minus f of 1 over 3 minus 1. And then you're going to say f prime of 2 is approximately equal to 13, even though you know that f prime of 2 is actually equal to 6. But you're going to use this because that's secant line approximation. All right, now give me like 2 seconds to just erase all this. Hopefully it'll actually go away this time instead of leaving the slight reminder behind. Wow, this brush is messing up my computer for some reason. Whoa, look at that. That's cool. Okay, whatever. Okay. That's weird. Okay. So now I'm gonna pivot to a different topic. That is the heart of all calculus, which is limits. The way calc goes is you learn limits, and then using those limits, you learn derivatives. Then using those derivatives, you learn integrals, and then in AB, that's where it ends. It ends with the integrals and like how you use them. But in BC, they start 2 units in there because why not? But that's where it ends in DC. But yeah, AB would makes more sense logically to me, but it's whatever. Anyways, back to limits. Think of a limit as a man. This is a guy. He's really sad. It's very important to my analogy here. as a man sprinting face first into a wall that this wall hates this man. I'm going to label it wall so you know this is a wall. He hates this guy. Absolutely hates this guy. But let's say we got, it's probably going to leave a white background, but whatever. Let's run this guy. Oh yeah, I'm getting really close to this wall, but oh no, I can't touch it. I'm getting really close, but I can't touch it. So basically, this wall is breaking physics for the sole reason of he does not want this guy to touch him. He has made it, he can get infinitely close, but no matter what he does, this guy will not touch the wall. Okay. So this wall, this is at this exact point is like 3.895585855562 latitude, whatever. We're just going to say this is for example, random number. We're going to say this is at 2. Completely random number. Definitely won't use that very soon. But basically, a limit's asking, as this guy approaches this random point space, once again, totally random that I'm using 2 here, as this guy is getting really close to the spot 2, this spot right here, what is he getting close to up here? Like, what object is he approaching? We're going to use value in a second. What object is he approaching as he hits 2? He's getting closer to the wall. As he gets infinitely close to 2, he's getting infinitely close to the wall. But he'll never reach it. So basically, I'm going to just make this into math. This dude, this guy, he's f of x. This guy is in, if you put it in calculator, it's going to say error. Probably. I think some say it the right way. But we're going to use the word undefined. You just put a dot here for undefined, or we're just going to spell it out. You can just say this part though. And then this point right here is called a point of discontinuity. That's not important yet. I just wanted you to know. This 2 is a point of discontinuity. So basically, that's a limit is just saying, as this man gets as close as possible to, he is using the force of all the Greek titans and gods, but he cannot touch 2. He is getting to 1.99999 repeat. He's trying so hard to get to 2. And when he gets to 1.9, it goes to 1.90. Oh, he can get closer. You can get to 1.99. Oh, but now it's 1.990. Now he can get to 1.999. Now he's just going to keep getting closer, but he'll never reach this wall. A limit is basically saying, as he gets close to 2, he's approaching the wall. All right. So now I'm going to show you the 3 ways to see a limit. Okay, just gotta do this erasing thing again. I really should have an easier way of doing this, but it's whatever. Okay. So now that we have that out of the way, there's 3 ways to show a limit. There's algebraic. You actually do have to know these. Algebraic. This is what's gonna. There's 2 that are going to show up in multiple choice. The third one is going to be more pertaining to FRT. Algebraic is basically the limit as it's written as lim because 2 letters was excessive for math people apparently. The limit, this part, limit as x approaches c. We're going to use c. C is normally used to say a constant or some number value, some integer. As x approaches c of f of x, which goes like to the right here. It's normally in the middle. I don't know why I wrote it like that. Actually, I'm gonna of f of x is equal to. They love to use L to say this on the AP exam and in the course description, so I'm just gonna use L. This is algebraic notation of a limit. We have the graphic way of representing a limit, or graphical, sorry, which is just like, point of discontinuity right there. There's the limit here of saying, as it approaches 2, it's getting closer to 2. And then there's descriptive, which I guess it's just the limit as x approaches c. I'm not writing this down. The limit as x approaches c of f of x equals L, but normally you're given c and you have to find L. So you'd say the limit as x approaches 2 of x cubed equals 6, or whatever it'd be. It's 8. But that's how you do that for descriptive. So now there's one more thing I have to show before I get to the that's not the right thing. Before I get to practice problems. And that okay. And that is I have to show basically what a limit is. So let's take this graph. We're gonna do this function, this guy right here. This function. I know it might be a little annoying to have that, but it was the easiest one I could think of that would have this point. The point I'm trying to make. So, in algebra, we know that anything divided by 0 is undefined. So anywhere this function's 0 is undefined. So x equals 1 is undefined. So an error. That is very important to the limit thing. So just make sure you know what undefined means. It normally means you're dividing by 0, or you're taking the square root of a negative number. That's also undefined. There's a few things like natural log of this is anything less than, or anything 0 or lower, or like stuff like that. But you'll learn them as you go. But let's say this is the point 1. Should pulling this up in Desmos real quick because I want to make sure I get this right. Okay, so it looks like this, and then this. Okay, so we're gonna. I'm just gonna say, if you see this graph, you're finding the limit of whatever this is right here. And well, let me take a step back. Let's say you're asked to find the limit as x. I should just write this over here. As x approaches 1 of f of x. This is f of x over here. Okay, we need to do stuff which isn't for this video. We'll do that later. We need to find what the limit is as x approaches 1. It's infinity. For this function, it's infinity. Okay? Looking at the graph, we can see, these numbers are going to keep going up forever. But eventually, if they were to touch 1, it would be at infinity, which it doesn't because you can't reach infinity. But if it did, it would be infinity. Okay, so let's say this is this point right here. This is y equals infinity. Y equals that number right there. So basically, the limit is saying, as you're approaching 1, what are you getting closer to? This function, as you're approaching 1, the function is getting closer to infinity. It's like that. So I'll show you some ways later on how to do that. But let's just get on to the 2 practice problems I've got to do. So I'm gonna write. I haven't thought of these beforehand, but shouldn't be that hard to make them. Might do that when they're harder questions. But let's say you have the function given f of x equals x squared plus 2x plus 1. Find a secant line. Oh, that's horrible. Approximation of the instantaneous rate of change of f at x equals 4. Okay? And this is remember, it's f prime of 4, but for right now, we're going to say the instantaneous rate of change of f at x equals 4. So, the easiest way to do this, when it says find secant line approximation, literally what you're going to do is you're going to say f prime of 4 is approximately equal to, and then we're going to do the y2 minus 1 thing, okay? It's absolute magic how easy some of the things of this could be. So we're going to do y2. We're going to pick random points. Let's just say one whole number in each direction just to make it easy. So we'll say y2 equals f of 5. We're just going to do x plus 1 and x minus 1. So this function is f of 5 minus f of 3, because y1 is f of 3 because 3 is 1 less than 4. So we're finding the function's value at x equals 3. Okay, and then just move these down here. All right, and then when we plug in 5, we get 36. You can put an equal sign here. 36 minus, and then 3 is going to give you 16 over 2. And then that's going to give you, you can once again put an equal sign, equals 20 over 2 equals 10. And then this whole thing would be your answer. Technically, you could just go like here. You don't have to do this over here, but to be a little more obvious, I wrote it out. But yeah, the approximation we have is 10. And to be perfectly honest, it is 10. It is in fact 10. So yeah, that approximation would be correct, but you probably wouldn't get points for the approximation. You get points for this right here, the setup. So just make sure if it's asking, I should get this in green so it's easier to see. If it's asking for you the secant line approximation, you're going to find the average rate of change from one below and one above a number, if you can. Okay, and then let's say, and do another easy one. Discussing the other topic we had. So we're gonna go with let's see. Okay, yeah, I have one. So we have this graph. I know my graphs are 4, but just ignore them. Pretend there's arrows on the side too, because we're supposed to have arrows, but I'm not drawing those. Okay, let's say we have we need blue so that you can see this. We have y equals x squared. We know this stuff. We're gonna say we're given y equals x squared. Okay, so we're gonna say write a limit. That is a horrible T. Wow. Function for y as x approaches 2. Okay, so now to solve this, it's very simple. We're just practicing writing limits. We have the limit. If it says write a limit, we're going to write lim for limit. I don't just make sure we're on the same page here. As x approaches, what do we need to find it as approaches? 2. Okay. Of, well, you could say you would say f of x, but it doesn't give it to you in f of x, so I wouldn't rely on saying f. If you're not given it in terms of f of x, don't say f of x. Just put the function there, and then this would be right for what the question's asking. This would be right. And then if it was like, oh, solve the problem, you'd have to use the stuff that we're going to learn next time. Like, oh, it's 4 because the limit here is equal to, this is 4 if where x equals 2, so it's 4. Okay, that might look easy, but I swear it's more complicated than that. It's not that simple. But, actually, it kind of is that simple. For most of them, it is. It really is that simple. But, let's say, I know this is completely irrelevant to the practice problem. Let's say there's this guy, an open circle. That's an open circle, by the way. Let's say this guy, the open circle is on there. You got to be like, oh no, I plugged in two because I'm assuming we made the jump to, oh, I just plug in X value. Okay, let's say, oh no, f of 2 is undefined. Oh no, what is this limit? What is this limit equal to? Huh? Oh, it's still 4. The wall's still there. We're just going through it instead of touching it, if that makes sense. I feel like that's a good analogy. You have the wall. In this case, the wall is there. We're just going right through it, and we never touch it. And then even if we wanted to come back the other way, we still go right through it, never touch it. Yeah. Anyways, do the practice problems or don't. That'll help, I promise. And watch these videos as you need them.